Hello everyone, my name is Giancarlo Ciudadano and this is part 11 of the HackerRank submission series. In this problem, we are going to tackle about two-dimensional arrays in the Java programming language. So what is a two-dimensional array? Basically, a two-dimensional array is a one-dimensional array. However, each element in this array is actually also another array. So basically, this is some sort of nested array as you would call it. So anyway, in this problem, we are tasked to uh, check the sum of this hourglass formation as demonstrated in this example over here and check for the largest sum in this 6 by 6 grid. So let's check our output over here. Basically, what I did is we are going to first declare a two-dimensional array using this expression over here and assign it into the two-dimensional array A with size 6 by 6. Next, we are going to declare the max sum. We can leave it as blank. However, we don't have something to compare it with when we declare this. When we compare the current sum with the current max sum or the highest sum, so we declare it as the lowest value. Since the numbers in this input can actually go to negative, the safest choice would be to use the lowest possible number in 32-bit computers, which is negative 2 raised to 32. So anyway, we create a new scanner object as usual, where the input stream comes from HackerRank, and then HackerRank is going to insert it into the input stream for us to be comparing with, so we can yield the expected output. So we assign it into the scanner object with the name scan or label scan. Next, we have this double for loop over here. Basically, what this does is it is basically assigning each in the input stream to a specific element in the two-dimensional array. You can do all of these in one loop, as I've seen, but I prefer this way even though it is less efficient because it is easy to modify and it allows more flexibility later. So once we have inserted all the values from the input stream to the two-dimensional array, we can then close the scanner to save up on memory. Next, we are going to this for loop, double for loop over here. So in this for loop, what this basically does is it compares the current sum of the instance of the hourglass shape with the current maximum sum, as we declared over here, to the lowest possible number. And then if it is the greatest sum at the end of these iterations, then it's going to print the highest sum among the number of combinations. So in this 6 by 6 grid, it is possible to have 16 different values starting from index 0 to index 4 only, since the shape extends up to 2 additional spaces over here into this average last shape. So with that, we can only loop the row and column up to 4 times, as also shown here. Since after that, if we loop this more times, it will actually go out of bounds. So anyway, we add the sum of the current iteration. So let's say this is the first iteration. We add all the numbers in the hourglass shape, which yields a value of 7. Then we are going to assign it into the local sum variable. Next, we are going to check the sum variable if it is greater than the current maximum sum. But since the maximum sum is the lowest possible number, it is going to change the maximum sum to the current sum. So the current maximum sum is 7. Then next, we are going to iterate again. We're going to move one space to the left. And as you can see, uh, the value yielded by this hourglass shape is 4. Since the current sum 4 is not greater than 7, we discard that sum and try again. So we do this 16 times until we get to the highest possible number as shown in this hourglass shape over here, which yielded an expected output of 19 as we exited the loop here. So in test case 1, we also did the same but with negative numbers and match the expected output, which is 13. So since we tested this 8 times, as you can see over here, it resulted in all of the test cases being correct. And this yielded us with 10 points to HackerRank, and then the website also accepted our submission as completed. So we successfully solved this challenge and we have successfully created a two-dimensional array. If you have any more questions, please let me know. And thank you for watching again. Bye bye.